solving a system of equations using elimination. And we're going to be focusing on linear systems. You want to solve a system using elimination if variables have opposite coefficients or if none of the variables have a coefficient of 1. If variables have a coefficient of 1, you may also use the substitution method. So in our first system, we have x minus 3y equals negative 15, and 5x plus 3y equals negative 3. And we notice right away that the y terms have opposite coefficients, a negative 3 and a positive 3. With elimination, what we're doing is eliminating one of those variables. And we're going to eliminate it by adding the two equations together. And since the y coefficients are opposite, when we add, they're going to cancel each other out, leaving just the x variables. So x plus 5x is 6x equals negative 15 plus negative 3 is negative 18. Divide both sides by 6, and x is negative 3. Remember, we are not finished. The solution to a system is the point or points. That is true for both equations, so we need an ordered pair. We need the y term. So to find the y term, we're going to plug x into one of the given equations. I'm going to plug it into the first equation. So negative 3 minus 3y equals negative 15. Add 3 to both sides. Negative 3y equals negative 12. Divide both sides by negative 3, and y is 4. So the solution to this system is negative 3, 4. And if this was graphed, it would be intersecting lines at the point negative 3, 4. Our next system, negative 2x plus 15y equals negative 32, and 7x minus 5y equals 17. None of these coefficients are opposites. However, we do notice that they have opposite signs. The x's in both equations, one's negative and one's positive, and for the y, one's positive, one's negative. So now we have a choice as to which variable we are going to eliminate. And what we're trying to do is multiply one of the equations so that the coefficients are going to be opposites. I'm going to go ahead and eliminate the y because I know I can multiply the second equation by a 3, and 3 times negative 5 would give me a negative 15y, and the 15y and negative 15y would cancel out. So negative 2x plus 15y equals negative 32 stays the same. You've got to distribute the 3 to the entire equation. So 21x minus 15y equals 51. So I wanted the y's to disappear, which they are going to. Negative 2x plus 21x is 19x equals, and then negative 32 plus 51 is 19. Solve for x, divide both sides by 19, and x equals 1. Again, we got to find the y term for the solution. So plug in x, it doesn't matter which equation you use. So negative 2 times 1 plus 15y equals negative 32. Negative 2 plus 15y equals negative 32. Add 2 to both sides. 15y equals negative 30. Divide both sides by 15, and y is negative 2. So our solution is 1, negative 2, intersecting lines at the point 1, negative 2. In this system, none of the coefficients are opposites. So again, you can make the decision if you want to eliminate the x or the y. Here, both are just as easy to multiply. I'm going to go ahead just to change it up a little bit and make it so that the x is going to disappear or eliminate. So I have to think of the least common multiple of 3 and 4, which would be 12. So I'm going to multiply the top equation by 4 and the bottom equation by 3. But keep in mind, one needs to be positive and one needs to be negative. So I'm going to make the bottom a negative 3. So distribute into both equations. 12x plus 8y equals 4, and negative 12x minus 9y equals 6. X's are going to eliminate, and we're going to end up with negative y equals 10. Divide both sides by negative 1, and y is negative 10. To figure out the x term, plug the value negative 10 in for y for either equation. 3x plus 2 times negative 10 equals 1. 3x minus 20 equals 1. Add 20 to both sides. 3x equals 21. Divide by 3. X is 7. So our solution is 7, negative 10, intersecting lines at the point 7, negative 10. All right, so again, our coefficients, we do not have any opposites, and we do not have any signs that are negative, and one negative, one positive. So I'm going to go ahead, take the bottom equation. I want to eliminate the x, so I'm going to multiply everything by negative 2. So 2x plus 6y equals 18, stays the same. And we're going to end up with negative 2x minus 6y equals negative 18 when we distribute. I wanted my x's to eliminate, but notice what's going to happen here. The x's are opposites, the y's are opposites, and even the constants are opposites. So this whole equation becomes 0 equals 0. 0 equals 0 is a true statement, so this tells us that there are many solutions to the equation, and on a graph, these would be the same line, one on top of the other. In our last system, we can see that the x has opposite coefficients, and so does the y. So our x and y are going to eliminate, leaving a 0. But 7 plus 12, those are not opposites. That's going to leave us with 19. 0 does not equal 19. That is not a true statement. So that tells us that there are no solutions. And on a graph, this system would be parallel lines.